Welcome to this Stratoss Lifecycle Manager 2.0 overview video. In this video, we will show you the new features and functionality that are introduced with version 2.0 of the product. The latest release provides a much higher level of automation and simplification of the operational lifecycle of cloud network services. With the increase in virtualization and softwareization of network functions, the complexity in managing end-to-end services increases as well. Traditional appliances are now made up of tens or hundreds of individual software pieces that all have their own lifecycle and need to work together with other virtualized and non-virtualized components that can run across multiple clouds, public, private, hybrid, or edge clouds. The different types of networking that are required to connect all these clouds and service components are becoming very difficult to design and maintain. In addition, services and components can be added, removed, or changed continuously, which makes it very complex and dynamic to operate. The amount of operational effort that is required to design and maintain these highly complex and dynamic services cannot be achieved with traditional tools that rely on manual programming and that will break the business case as more and more people are needed to manually design and maintain these services at scale. Stratoss Lifecycle Manager provides a set of tools that allow the service provider to fully automate the operational lifecycle of these new network services so that they can deploy more services at scale, faster, and with a predictable, much lower cost. Stratoss distinguishes itself by providing a much higher degree of automation than any other tools, and especially for the day zero use cases of onboarding, designing, and testing of new services, for the day one use cases when services are being put to production, and especially in the day two scenarios where Stratoss fully automates the more complex use cases such as migrate and upgrade. At its heart, Stratoss Lifecycle Manager has an intent-driven automation engine that works like a satellite navigation system in your car. Just like with the sat-nav, where you only have to enter the destination where you want to go, the intent engine brings the service from its current state to the intended state in a fully automated manner without the need for manual workflow programming. Stratoss Lifecycle Manager 2.0 also includes a CICD Hub that automates and simplifies the design, the testing, and change management of your VNF and network services. The unique inbuilt behavior-driven test tools enable you to automate the testing of all possible life cycles and end-to-end service behavior. This higher level of automation results in significant effort and cost savings for the service provider. What we have seen from deployments is that it can save up to 80% of effort in the design and test phases, and we can also achieve over 30 times the operational savings and efficiency gains once the services are in production, and especially for these complex day two use cases that with Stratoss are fully automated. So why are we so excited about version 2 of the Stratoss Lifecycle Manager? As mentioned, it really raises the bar in terms of functionality and automation it delivers. First of all, there's a completely new user interface that simplifies the design and operations. There is a graphical designer that allows you to design VNF and network services by simply dragging and dropping. The unique integrated behavior-driven test tools allow you to easily create fully automated operational tests, and we will see that in a demo. The intent execution views have been significantly improved so that you can also see the history of what tasks the intent engine has executed automatically on your behalf. We've also introduced the CICD Hub, as mentioned before, which we will take a look at in a demo. And other improvements include role-based access control, industry standard Helm chart for easy installation, improvements in logging, high availability, security, and also search functionality. So let's go and see some of the 2.0 highlights in the demo. In order to show this demo, I'm going to log in with one of the users, which is Jack. As mentioned, we now have role-based access control, which means that different users will see and have access to different parts of the user interface. So on the left side, you see different views for operations, for the designer, for system administrator. So for example, the system administrator is able to add deployment locations, he's able to add different resource managers. You have a designer view that will come back later, and then you have an operations view. So the operations view shows you the most kind of recent instances that you have instantiated. So in this view, I can see all the kind of most recent changed instances that I've instantiated. So you see what state they're in, you see their descriptor that they're using, you see the last intent that was run, You'll see also the CD status. And what you can do here for an already existing instance, you can basically change the intent or you can change the state of that instance. So I can make this, for example, inactive. I can upgrade that to a newer or older version of the network service. I can uninstall the network service. I can also look at the topology. So if you open up this network service, which is an EPC network service, you can see that it consists of multiple VNFs inside of this network service. There are VNFs and there are also referenced networks, so networks that need to be in place and we need to be aware of in order for us to connect to those. So you see here that these are all the networks and these are all the VNFs. And again, you can change the intent here, and you see some of the properties on the right side. If I go to the most kind of recent assembly instance view, I can create a new network service. So in this case, let's say I want to instantiate a new voice service. I select the descriptor that we have, which is already onboarded. So in this case, I select this one, and I choose this service to be in the active state once this intent is run. I click next. There's a couple of properties I can still change. In this case, I'm just going to write here the overlay network that I'm using, and I'm going to leave the rest blank. So then when I now hit the create button, the intent engine will receive the intent request to create this and instantiate this network service. So this is where the intent engine then picks up. And if I go here, you see that it's in progress. If I open up the execution view, you see all the different tasks that the intent engine is doing. So this is what we call the intent execution view. So in this case, it knows or checks from topology what are all the different components of this network service that are already up and running. Then it will figure out, okay, these components are up and running. These components I still need to install and bring through their kind of life cycle of install, configure. So you'll see that happening here, where basically the whole service is being brought to life. So you see various tasks that are progressed here. So this is going to take quite a while, so I'm not going to go through this, but you can imagine, I mean, this is quite a simple service, but you can imagine if this is a much more difficult or complex service like an EPC, you'll see that the execution history or the execution is taking quite much time, and quite many tasks need to be completed, and a lot of kind of interdependencies between the different components. So as we saw earlier in the topology, we saw that the EPC had multiple eNodeBs, it had networks, all of those need to be brought through their life, and you can see that the intent execution view starts to be quite complex. And imagine if you have to program all of these steps manually. In this case, Stratoss Lifecycle Manager, the intent engine, really fully automates that part. I can also look at the dependencies. So these are all the dependencies that are between the different tasks and between the different steps in the execution. So, for example, sometimes a VNF needs to be instantiated before another VNF. Sometimes there need to be some properties that pass between different VNFs, like my VNF is ready, I need to pass my IP address to the other VNF so he knows of my existence. So all those things, if you would have to program those manually, it would take quite a lot of time. And this is just a simple kind of EPC here with one intent, which is the instantiate. But imagine if you have to write all that workflow for or program all the life cycles for all the different VNFs, for all the different possible life cycles like upgrade, migrate, etc. If we now move to the designer that is embedded within the Stratoss Lifecycle Manager, when I click here on the designer, I basically enter a screen where you have a long list of VNFs and network services that have already been designed and onboarded. I can filter them and search to them by name. I can create a new VNF or a new network service descriptor. But I'm going to show you one that we have already designed, which is the PBX. So when I open it up, I enter into the actual designer. On the left-hand side, you'll see a top-level VNF descriptor. It has a version number, it has a name, etc. And on the right-hand side, you see the VNFC that is embedded within that VNF. You can have multiple VNFCs inside of the VNF. And you'll notice that in Stratoss Lifecycle Manager 2.0, we are adopting a more Etsy-like structure of VNFC, VNF, and network services. So when I open these two elements up, I can basically see the properties that are a part of that descriptor, or the properties that are part of that VNFC. You'll notice that there are some blue lines going from one to the other. So those are properties that are being passed from the VNF, in this case, to the VNFC. And when you look on the right hand, there's two properties here that are being passed from the VNFC into the VNF. On the right hand side, you see the similar properties that you can edit and modify. In this case, I've selected the VNFC, it was already onboarded. You'll see the properties. You also see the different metrics. In this case, we have defined a metric for integrity, which means that it's checking every publication period if that VNFC is still up and running or not, and then it's using that for the healing of that and the healing policy of that VNF. So that's, let's say, the design for the VNF. Let's now take a look at the actual network service. For the voice network service that we've just stood up, I can open up its design, and you see a similar view that we just saw with the VNF. So on the left hand side, you see the top level network service descriptor, and then you see a whole bunch of elements. We can add elements, but the elements that are included in this network service are a VNF for the gateway, a clustered VNF for the VoIP server. We have an internal network, and then we have some overlay network that we are referencing to. Similar to the VNF design, you see the blue lines indicating properties that are being passed from one to the other. And again, you can just do those by just dragging and dropping. So if I hit, for example, if I select one of the properties here, I can just drag and drop them in or out to the other elements. In this case, we also see an orange line, and the orange line is a relationship between these two components. So relationships are very important so that the intent engine knows when, for example, if there's a dependency between two VNFs, so if one VNF has to be instantiated before the other VNF, or, for example, if there are things that need to be passed once a certain VNF has been completed. So in this case, there's a relationship from the VoIP server to the gateway, and what this means is that once the VoIP server has been instantiated and is in the active state, it should pass its IP address to the gateway, so the gateway knows where to send the traffic to. This is very important so that the intent engine knows when to execute certain tasks. If I open up the gateway, we'll see the properties on the right hand side. You also see the relationship. So again, you see that the source is the VoIP server. It's after it's instantiated and it's in the active mode. The target is the gateway, and then these are the operations that are being called once these conditions apply. You see the operation here, which is the add to dispatch list, delete from dispatch list when the VNF is again removed. You also see the number of metrics, and if you look into the VoIP server, you also see that it has a clustering section, which is filled in this case. So the VoIP server can be clustered, and in this case, the initial quantity is 1. The scaling increment is 1. There's a minimum and maximum nodes you can define, and then it shows you the scaling policy for this. So the scaling metric that it's using is the load on the gateway. In this case, if that hits a certain threshold, then it should wait for a smoothing period, and once that is met, it will basically then execute the scaling of that automatically. If you're happy with the design, you can save that, which will save the network service descriptor. And I'm going to now show you one of the unique features that is integrated into the Stratoss Lifecycle Manager 2.0, which is an integrated behavior-driven testing. So for this network service, I can define a number of automated tests that should be run. You first might need to set up some components that you need to be stood up alongside with the tests. So these are components like a traffic generator that simulates traffic through your network service, or components like a probe that monitors different metrics. So once you're complete with that, you can then go and define your actual test scenarios. You can create new test scenarios, or in this case, we've already defined quite a few tests for this voice network service. So there's a test here for load, there's a test here for heal, there's also a test for skill. So let's open it up and take a look. On the right hand side, you have all the different steps and tasks that you can define as part of your test scenario. So for example, you can create new network services and you just drag and drop them to the middle part. You can scale out a cluster, any type of intent or any type of metric or any type of utility like waiting for 30 seconds. You can just pick them up from the palette here and drag and drop them on the left side. So on the left side, in this case, the scale test, you can see from top down that first what we're going to do for this test is to create the network service, put it into the active state. We're then going to instantiate a number of the components that we need as part of this test. So for example, the traffic generator. So once those are all put into the active state and are instantiated, we then have the actual steps for your scaling. So we're going to define some metrics, which we're going to record. And then you see here that when I upgrade the network service called the traffic manager, which basically means that we are upgrading the amount of traffic that the traffic manager is sending through the network service, then we expect to see a scale out. Then we're going to wait for 30 seconds, and then we're going to upgrade, or in this case, kind of downgrade the traffic generator again to the previous version, which means that it's sending less traffic, which will then want to see a successful scale in assembly. And then when I've done that, I then stop all the recording, etc. Now this is the definition of the test scenario. If I then, if I would run that, it would take me quite a while to actually run that. But I can look into the actual results. So all the results for the tests that you've run are stored. They're stored inside of Kafka. In this case, I can see that I've already run a successful scale test. You see all the steps and all the stages that it went through. They were all passed. And you also see the metrics that were recorded during that test, so that you can also see, for example, you can compare different VNFs, different versions of VNFs, etc. I now have a network service design and behavior tests for that service. I now want to package that up and make it available to others to use, or move it to a pre-production environment where I can deploy additional tests, all as part of a continuous integration, continuous deployment process. This is why the 2.0 release comes with a set of reference tools in what we call the CICD Hub that you can use to automate your CICD process. The CICD Hub provides tools that allow you to develop and onboard VNF and network services, and then package and move these to various pre-production environments for testing in a fully automated pipeline. On the other side, once your services are already deployed, I need to upgrade or change these, and the CICD Hub ensures that the changed network service has already gone through a fully automated pipeline and various automated tests, so that I'm very confident that when I move that out to a continuous deployment, that the service is going to work properly. In the CICD Hub, there are a number of reference tools, such as Jenkins, that provides the automated pipeline that you can set up for your own service, a Nexus image repository, and a Git source code repository that I'm going to show you here. You can use your own, but it also, you can also use the one that is bundled with the CICD Hub. So in this case, this will store all your VNF descriptors, all your network service descriptors. So we just looked at the IPPBX, where you have your descriptor, your VNFC. We also have the voice service here that we defined previously. The CICD Hub also comes with a repository. So this is where you would store all your tested and packaged VNF and network services. You would also store your software images here for your VNFs. But one of the more important parts of the CICD Hub is an automated and continuous building system. In this case, that's Jenkins. So what Jenkins allows you to do is to automatically create a pipeline that automates a lot of the steps that you would typically do manually. So in this case, when you're developing your IPPBX, every time that someone makes a change, you can have a pipeline that says, okay, if someone makes a change, it will then check out this VNF, it will get all the related components, it will onboard in this case, the IPPBX to a test lifecycle manager. It will then run through a whole set of tests, and once that's complete and successful, it then will package that PBX up and put it into the repository, so people can take it from there and they know that that VNF is actually working because it has gone through an automated pipeline. So similar to the actual PBX, you can also have an automated pipeline for your voice service. So in this case, if there's any change into your voice service, in your network service, for example, it could check out all the different components that it needs. It fetches those, it onboards those, it onboards the voice servers to an existing lifecycle manager. It will then run through a whole set of automated test scenarios. And these could be the ones that we just defined. So here you can see, for example, it's testing the doing some basic tests, it's doing a load test, it's doing the scaling test that we just defined earlier on, it's doing a healing test. And once all of those are passed, it will then package that network service up, and again, we'll put that package and fully tested package into the CICD repository, which in this case would be Nexus. So in this way, you can see that how your VNF and your network service will move in a quite automated way throughout your organization, going from the initial design, development stages into the continuous building, continuous integration, continuous testing, so that once these services go into production, they are of much better quality and are less error prone. Thanks for watching this Stratoss Lifecycle Manager 2.0 walkthrough. I hope it gave you a good view on why Stratoss enables a much higher degree of operational automation so that service providers can launch more services faster and at a much lower and predictable cost.